Hello, everybody. Thank you guys so much for joining our talk. I know it's the last session before lunch, so please hang in there. My name is Maria,
And I'm Michael Hogan.
and today we'll be talking about demystifying drone development. So just a little bit about me. I currently work as a developer relations engineer at a Kubernetes accelerator called Kubeshop. My background is in developer education, software development. I'm a big Kubernetes girl, so after the talk, we can talk about that. I've also worked with O'Reilly, and this May, I'm USC, University of Southern California, class of 2023 for industrial systems engineering. And then my fun fact is that my dog is at this conference, but he's in my room right now.
All right. And hi, I'm Michael Hogan. I'm the project mentor for the senior design course at USC. My background, I'm currently a product manager. Focused most of my career around developer and user experience and tool creation. And I was USC class of 2005 and 2006. So it's fun to be back mentoring the design course that I was in as a student. And my fun fact, I've mentored over 100 high school and college students in STEM projects, largely using open source. So thank you for the open source that you publish.
So just a quick overview. So we're going to be talking about the ISC 495 course, which is a senior design project that I worked with Michael on. We're going to be talking about the value of accessibility from both the industry and the student perspective, talk a little bit about the project and opportunities that we can take and move forward as a community to just improve developer experience overall.
All right, so let's start with looking at the course. So ISC 495 is a 2-semester course, takes a year to complete, and in the fall we focus on problem definition, and the goal is for the students to investigate some mission situation that they're trying to create a solution for, understand the real problem, identify root causes, and simulate a potential solution, and then pass through a preliminary design review. In the spring semester, the focus switches to solution delivery and more hands-on prototyping. The goal is to detail out a proposal, order parts, get that experience of ordering hardware and dealing with supply chain, and pass through the critical design review, and then implement the design and summarize results. And then we have a feedback loop between the university project course and a STEM summer program for high school students. The university students work out how to use technology and kind of expand what is possible during the one-year course, and then the high school students apply it in the summer in a compressed 10-week time frame, and then we iterate based on feedback from the high school experience. All right, so now we'll talk about accessibility and why that's important. So when we're thinking about accessibility of working with college courses, working with high school students, from an industry and education point of view, there's a number of challenges. Intellectual property restrictions, access to tools, access to the real world systems, safety, keeping the students from being in a situation they might get hurt. Curriculum, so access to educational curriculum materials that can be used in the classroom. And team composition. You don't know where the students are coming from when they show up to your class or to your project. You don't know what background they have, what skills they bring. And then on the engineering side, the challenges include system complexity, the need to have multidisciplinary skill set to even work with a robotics type system, and then the level of realism. So can you give the students an experience that's representative of what they would get in a real world workplace setting on a real world project? So open source helps address the first two of these and a number, but really it helps with IP restrictions, and it helps with getting access to tools. So immediately the cost barrier is lowered, there's less approvals needed, and it's easy to talk with the students about the full level of detail of the system to any level of detail they may be interested in and want to dive into. In terms of real and relatable, it is a real world system. We see, especially for Dronecode Foundation, that the project is used in real world drone projects to start businesses and to create components that are used in commercial products. And then we have accessibility. So there's, by the nature of having open information and documentation and tutorials, maybe videos, there is some degree of curriculum, and there is an opportunity to have the project be adaptable depending on what skill set students show up with when they engage with the product. Worst case, you could fall back on doing market research type projects. Best case, people might dive into containers or enhancing aspects of the open source ecosystem around PX4.
So from the student and community perspective, so I believe that accessibility is about, first of all, with more people, you have more projects. So by having more people involved in the project, you have more innovative use cases. So just by having, a variety of students from different backgrounds coming from different disciplines, you can apply drones to all sorts of real-world use cases. And then coming from my developer relations background, more contributors mean faster releases. So if you're just depending on a very small development team to manage the software development process for an open source software, it can slow down the release process. It's really difficult to increase features and really improve the whole process. But by having more contributors in the space, you can divide up the work evenly, and you can lean on their expertise in different subdivisions. So one example is like the space of containers. So by having people with backgrounds in that space, it's easier to roll out those kinds of features. And then additionally, it's better experience. So good onboarding is critical for user retention. So a lot of times when we think of these open source projects, it's a group of people who are interested in something, but what happens when they stop being interested in it? What happens when they retire? So what happens to the community and the software after that happens? So it's all about maintaining the health of the community so the project and the software can live on after the founders are done with it. So I'm just going to talk to you a little bit more about the project that I worked on. So this is what we set out to do. And now that I'm looking back at it, these are very ambitious goals. So we wanted to install and operate QGroundControl and Gazebo to evaluate the current mission planning and execution process. So we were using that design systems background to really improve the execution process. I wanted to containerize installation process because we're thinking about the barrier for high school students, because not all high school students have the same access to hardware like college students and real-world developers, so we really wanted to lower that barrier to entry. We wanted to write clear instructions for the installation process because there were 5 people on the team and we really struggled with even getting started, so we really wanted to redesign that process. And then finally, design and execute simulated real drone flights. So this was part of the hardware building process. So it was relatively easy to build, but very difficult to get up and running. We struggled a lot with the hardware software interaction. I think because none of us are network engineers, I think that was the biggest challenge. And then I think the funniest one is the fact that batteries were not included, and we all thought they were. So poor Michael had to drive 2 hours to get us batteries, and that really slowed down our process. So even something as simple as including batteries into the beginner kit that you give people and tell them that that's all you need to do, I think is just one easy way to include more people, because a lot of times we were very frustrated to the point where like, do we even have to finish this project? Like, can we just just kind of put the drone in the air and pretend it flew? But that's not, we want to keep people interested, so we really want to make that process easy. Like, imagine how hard it is to get started. Like, if you're struggling with that installation process, you're not going to want to complete the project. So it's really about making it easy and still fun to do, because this is stuff that you do in your free time. And then for software configuration, so some of the things we ran into, we felt like the documentation was insufficient, especially because all of us had Macs, and we really, really struggled to get everything installed. I think the installation took like 6 or 7 times for us to do, which is really difficult because I only had the Git background from my job that I took a semester off to do, so I can't imagine what it's like for students who don't have that super heavy computer science background. So I feel like you shouldn't need a master's degree to install drone software. So I think we really need to reevaluate how we view documentation. And that's part of like the first thing that we were talking about, how if it's open source, just because it's free doesn't mean it's accessible. And then we really struggled with actually getting the gazebo software working with our drone and like connecting it together. So I think just we need to implement better tutorials for that. So here are some project outcomes. We were able to get QGroundControl installed and up and running. We were able to build a simulation with Gazebo. We were able to build and calibrate the drone, but we're unable to fly it due to a rotor malfunction. That's what our consensus was. However, there was a lot of learning. Like, I believe that we're in constant practice, so even though we didn't get the drone to fly, I don't consider that a failure at all. I think just even the idea of us going through this process and like making it easier for the class of 2024, 2025 is a big success. So we learned a lot about like the troubleshooting process, how to like look for resources. So we were able to get on a community call and even just like talk to people in the community, which is not something that we were familiar with. So even just laying down that groundwork for the next students was amazing. And I kind of gave myself like a little operating systems 101 course just to get everything up and running, which was, I guess, helpful for my future and working in this space. So here are some opportunities. I think for overall developer experience needs to be at the core for building all open source software because like I've said before, a lot of this is done in people's spare time. So if you really struggle with getting started, you're not going to want to stay with the project. You're going to want to move on to something that's easier and more welcoming. So I think we need to really think about all perspectives, not just the perspective of a senior or staff engineer when we're building documentation, when we're building tutorials, when we're building kits. Please include the batteries. We want to make the hardware instructions like pretty much, I don't want to say like mistake-proof or idiot-proof, where everything's included and you can just easily get going in a reasonable time frame. We want to have device neutrality for software because not everybody has the same level of access for things, and I feel like the way that the industry is going, that's really possible with containers especially. And then on the community side, we really want to establish a feedback loop with educators and course building. So make a space for a safe space for students and really early beginners to be able to reach out to people and really focus on community resources. So things like workshops, webinars, more blogs talking about the user experience, I think would be so helpful for that. And then just really energize the new talent that's coming. So imagine what it's like to have a bunch of interns that come in who already know how to use the software already because they had such a positive experience. They want to continue it on with their careers. So there's a lot of opportunities here that I think by just implementing developer experience at the core will really improve the community. So here are our closing thoughts. So it's not open source if it's not accessible. So open source does not just mean free. It means accessible to all. Open source enables hands-on experiences. So just by having this experience of working with drones hands-on, I'm just here at a drone conference. Never in my life would I think that flying drones and programming drones was something that was available to me. So by having a open source alternative, I think is really powerful in giving people from all backgrounds that experience. And then developer experience really does accelerate community growth. So once you lower that barrier to entry, you'll see almost like you're opening the floodgates to all the people who will come in and enrich your project. And then university project courses are a great way to help validate your developer experience and improve your product overall. And then just, since this was a community effort, I just want to say a special thank you to my teammates and my professors, and Michael, of course. So Troy, Ayla, Andre, Ariad, and Professor Mayashiba and Professor Lowe. So yeah, thank you.
All right, thank you.
Do we have any questions? All right, you're right there.
The hardest things to get students to work with this high school college is getting the funding for the drones. How do you get that?
The funding problem?
The drones, buy the drones, so it's like it's stupid.
Yes. Yeah, I don't think there's an easy answer to how to get the funding. It's been a combination. In the first years that we tried it, I bought the drone kit myself and just donated it to the university. The last couple of years, we were lucky to have the university sponsor purchase of the drone. And one of the ways that we enabled that was incorporating it into the learning process by using, by asking the students to create a bill of materials and go through the process of a purchase order and having to deal with the supply chain. During COVID, that was a huge thing. We weren't able to get parts because there were no, I think we were trying to use a Raspberry Pi maybe for something one semester. There was no Raspberry Pis for like a year, right? So, yeah. So that helped the university get excited about contributing to purchasing the kit. And it also brought some of that real world experience into the project course, because then the team gets to see, oh wow, okay, the part doesn't show up on time. What do we do? How do we find a replacement part? How do we find an alternative? So, yes. It would help, obviously, to have maybe some more entry-level kits at a lower price point. Previously, we were using the DIY robocars for this course, and I think those kits were in the $200 range, all included, and that was an easier ask. So, yeah. We fill the gap with the simulator. So having the simulator is a big help to filling the gap. Sometimes what we'll do is, with the high school students, for example, where we have a bigger group of students, is have one team that maybe gets a drone, or a couple teams that get a drone. Everybody starts with the simulator. And as people progress through, teams that are kind of moving ahead faster end up being the one that gets the hardware kit. Great. Any other questions?
Questions, comments, concerns?
So as a new developer, what is the worst part for starting out that you found? So for me as a maintainer and developer of other some software, it's really important to bring in new people. That's my hard part. When I started with one, but I was already an expert. So what were the worst parts, and what would you say that we need to help fix?
Honestly, the worst part was just like, how long, okay, so I feel like it's better, so the documentation, I went through it, and I read it twice, but it still took me like 4 tries to download the original QGroundControl. So I feel like if there was even just like a guided tutorial of somebody's screen sharing of like how they did it like step by step, because I think we put a lot of, like, I am fluent in the terminal because of my job that I just happened by coincidence to do. But if I'm just brand spanking new, that's not something I'm super comfortable with. So even just having like somebody screen share, perfect. I would love to see everything step by step, because when you read the documentation, there's a lot of like things that are implied that you already know.
And just my observation on that, because it was a surprise to me, when I was in college, I think I was the only one at USC that had a Mac the year that I was in Computer Science 101. But now, when I go in and meet the freshman students, half the people in the room actually have like iPads as their primary computer that they're trying to start with. A lot of people have Macs. Windows computers are actually maybe on the decline to some degree, and very few people that are students are able to afford having a secondary computer that's primarily a Linux computer running Ubuntu. So that multi-device accessibility is a key opportunity.
Yeah, that was really frustrating for me. So I really wanted to like take it to the next step with that container project, but then I was trying to use like my school's, VM, but then it was like a huge privacy problem, and I had to like call the IT department and do all these things. And by the time all that happened, graduation was there. And I was like, oh my gosh, all this wasted time just because it wasn't iterated for my operating system. Like, I shouldn't have to have a second computer to like expand on the work that I've done. So I think just even that is important.
Yes.
We would like to know or hear from you, how was the integration, the version, and the equal of the course? I mean, you have a lot of problems to face, a lot of problems to solve. How this work integrated with the course?
So those problems are actually part of the learning experience, and that's part of the goal. So that's the good news, I guess, right? So as long as the problems are encouraging the student teams to interact with the Dronecode community on Discord or learn how to troubleshoot and seek out information, then actually the problems are value added. And we like to have some degree of problems around to encourage those experiences. That's one of the learning outcomes we're looking for.
Yeah, and that troubleshooting process is like so key. Like just fighting with my teammates on GitLab, that's a real world experience that you need to have of like even just like estimating man days for engineering projects. When people think, like one of the girls on the team was like a competitive swimmer, so like estimating man days to include the swim season. Like those are things that we don't think about when you're going into these design projects, because before this project, most of your projects were done solo, so you were basically the only variable. So like really dealing with all these variables that are outside of your control. I think that was one of the biggest learning.
Yeah. And the other aspect to that was adjusting the project scope over time and getting that experience too. That's another learning outcome that we're looking for in this course, is the students interacting with the mentor to rescope the project based on how things are going, based on what outcomes now seem realistic, in the time frame available. Yeah.
One of the comments you made was that so you don't think we need computer science backgrounds to run these programs. But in my industry, like I work in the software industry, it's helpful to have computer science. We recently went through this year, previous year, we had a couple of different interns. One of those interns, we had to teach them how to use Git. I saw that on your slide as well. I'm just wondering, how much synergy is there between computer science and do you recognize having whole industry projects? What source control tools do they use, and would it be relevant to have that as a prerequisite course?
Can you summarize that? I
Yeah,
lost you at the end because there's.
So the question was, how much do we expect students to be familiar with Git or
Okay.
source control tools, and would it be helpful to have an introduction to that as a prerequisite to the course? So
Yeah, I feel like Git is not something that's at least I'm only going to talk in the context of USC. I don't think that's currently in the computer science curriculum until the very end. And this was not a computer science project. This was a industrial systems engineering project that implemented computer science principles. So I feel like, a lot of these projects are interdisciplinary. So therefore, we have to also understand that people are coming from vastly different backgrounds. So if, a medical team wants to build drones to deliver blood to hospitals, they should not have to have, a really advanced computer science background just to test out that project. So I think it's the way that we reframe it almost, to make it more accessible. But and maybe this is another conversation entirely how I view computer science education currently, but right now it's not there in the curriculum. So I think when we're opening things up and calling things open source, we should keep that in mind. So even just having a little note of here's some Git resources before you start doing this project, and put links to it would be so helpful so you have a place to start.
And I think another important angle on it is a drone is a robotic system. So it's not just about the software. And I think for a student whose intention is to go into a career where they're working on the Autopilot software, it's totally reasonable to expect a background in source control or an interest in picking up those skills. But if the students coming in from an electrical engineering background or a mechanical engineering background, and they're interested in creating a payload, or maybe they're coming in from a mission background where they're interested in using a drone to achieve some task, and they're blocked in achieving that task because they haven't learned how to work with Git. That's where it starts to be potentially a disadvantage. And so in those cases, we do try to kind of have a sidebar. Okay, let's set up a lab and get people in a room and learn how to use the command line, learn basic source control. That's another goal of what we're trying to incorporate in the course.
Right. And I think just when I was talking about accessibility, I think just having a prerequisite section of saying like this is everything you really need to know, and not just like here's just what the kind of software you're using, of like here are the concepts that you need to know before encountering that, would change a lot of this, like this whole presentation would be a one slide thing. But sorry, I missed your question.
It's really awesome. I think this was like a really great environment to try something open source, like really uncover a lot of the problems in like a really nice and structured way. And so I'm just curious, part of your course, or if you consider adding to part of the course a section on explaining documentation to the open source community about things that you need to know, or like if you're like a true beginner, like you're gonna get, or like this is how we built our network, or just anything about that.
So I think there's definitely an opportunity for this course or courses like it to contribute back, patch requests, and we'd be interested in learning how to do that, more effectively. And so, yes, if you have ideas on that, I'd love to follow up on that. But anybody in the room, that is, how do we teach? How do we teach students working with Dronecode to create a patch and create a merge request so that it's going to be easy for the Dronecode Foundation to process that merge request? We're interested in learning that and incorporating that into our process.
I saw your hand.
Yeah, just a very tiny part. You have these awesome things on GitHub, which are basically purely basic things that people can make if you're talking config. What you guys do, you try out a bunch of materials, you get a lot of walls, and you write them down and figure out how to progress. But I think if you look at this actually is, that would be a very fun way of document your stuff for the rest of the world. You see this very natural obstacle for it just really this is an idea.
All right.
Yeah.
Not an efficient day, but I usually see what's awesome in Git, and you find this random topics. Yeah.
Okay. That's
Thank
a good
you.
idea for the next course. Yeah. All right.
All right. Any other last questions? All right. Well, thank you very much for
Thank you.
making time for our talk.